Hai, Assalamualaikum and salam sejahtera to all the attendees today. Thank you very much for attending our webinar today. Our topic today, we would like to discuss on the journey of the digital transformation. Today with us, we are having two prominent leaders in the technologies. Our first speaker is Mr. IR Dr. Chee Fai from Robolab Technology Sdn Bhd, and also Mr. Mano Subramaniam from the PSS, actually Packaging, Sales and Services Sdn Bhd. So welcome to our speakers today. So first of all, I would like to address our agenda for today. Our flow is like this. We will start with our first speaker, Mr. IR Dr. Chee Fai, and followed by Mr. Mano Subramaniam. So at the end of the session, we will conduct the Q&A session. So stay tuned with us, and then all of the attendees and participants, if you have any question to answer, you can write in the question bar. Yeah? So for the start, I'm Mazlina Shafi'i. I'm the program manager for the productivity, machinery and equipment productivity nexus. Nexus, yeah. So I'm from the MPC, Malaysia Productivity Corporation. All do you know that currently MPC have launched productivity 2020 for 2020, yeah. So the reports reported that our productivity growth dropped by 5.5%. That means we are in the negative states, yeah. All of these growths are contributed by the very unfavorable performance from the enterprise as well as the sector level to contribute to the low and also to the negative productivity growth. So to improve the productivity, of course, we need the pushing factor. So one of the pushing factors is through the digitalization. So many studies associated digital technologies and productivity, like study reported by the Harvard Business Review. They said that the most digital companies are outsized growth in productivity and also the profit margin. So the three main area actually in the digital technology which improve business performance and productivity, namely digital assets, users and also workers. So providing these digital tools to employees to perform tasks, enhance their productivity. So today we would like to address how we want to start the journey of the digitalization from our speakers, and then basically our speakers will discuss on the four main topics. So our first speaker, let me introduce our speaker, Mr. IR Dr. Tan. Dr. Tan actually is the Chief Technical Officer from Robolab Technology Sdn Bhd, advisor and mentor for our MPC Productivity 1010 initiative. He is also the permanent members, Technical Committee on Smart Manufacturing Department Standards Malaysia, and also the technical expert partner IEC ISO Smart Manufacturing Standards MAP. So I also would like to introduce our second speaker. Our second speaker, Mr. Mano Subramaniam, CEO of Packaging Sales and Services Malaysia. He is also ESCO members of Malaysia Automation Technology Association. Have many over than 30 years experience in the field of packaging and plant automation. And also the field in the machine building for the past 20 years. He also pioneered Industry 4.0 ready machines since 2016. To date, he has built and installed more than 8 lines which are fully Industry 4.0 ready. And also, He is also the provider for the customized machine and turnkey solution. So without further delay, I would like to invite Mr. Tan to deliver his presentation. Please, Dr. Tan, please welcome.
Okay, thank you, Dr. Mazlina, for your kind introduction on me. Please wait for a while. I'm sharing my screen. Okay, can you see my slide, right? Okay, testing. Can you see my slide?
Yes, good.
Thank you. Okay, first of all, I would like to thank you, a big thank you to the Malaysia Productivity Corporation, especially the machinery and equipment productivity nexus, under the leadership of the Dr. Mazlina, to invite me to give sharing with you all the bosses, owner, entrepreneur in Malaysia. So today I would like to share my topics on the journey of the digital transformation. First of all, if you have any, if you have problem with on my slide or the voice, please do inform me, because I just have one-way communication on it. Okay. I'm from Robolab Technology Sdn Bhd as well. So this is some of my profile. I also very much actively involved in locally, regionally, and as well as internationally. Okay. Top page. Not means that if something happened now, right? Now it's a EMCO for the Klang Valley. I think it's a very tough time for most of the industry, not only for Klang Valley, but as well as the whole Malaysia as well, because the pandemic cases is not still very high in Malaysia. It's a big impact. Yesterday I watched news, right? I know that Malaysia purchasing manager index, right, is dropping. I look at the index, right? In April it's okay, but in the May until now, actually PMI is dropping. If PMI index is dropping, means that the economy of Malaysia is not good at all. So now is the worst of the time, because the pandemic is already impact the people, not only Malaysia but the whole world. I think for industry, if you are not under essential industry, you're not allowed to operate as well. If you're essential, you can operate with a certain percentage of the capacity. But now for EMCO, right? I think in Klang Valley, many of the industry not allowed to operate. For now, it's the worst time. Worst of time. So I show you Taiji not because I want to play with Taiji. It's a serious topic, because normally in the Taiji we look at the yin and yang. Okay, so normally we look at the crisis. Okay, always come with an opportunity. Okay, that we look into a crisis as a something that can give us something as well. So when we look positive, we look at it as an opportunity. So the former Prime Minister of the UK said that never let the good crisis go to waste. Right? Don't let the good crisis go to waste. So we need to have a positive thinking. Okay, how to we survive? Now, of course, survival first, and then try to think about how we're going to get something out of it. Right? So we need to embrace the change. Okay, not because pandemic crisis, then a lot of things you say it's a barrier, it's a constraint, but we need to look positive. How do we going to change ourselves, our operation, our business, our country, economy, and etc. to be better, okay, and then to face the better future. So of course, we wearing masks. Based on World Economic Forum statement, there's no returning to normal after the COVID-19. Okay, now the COVID-19 is not yet over for Malaysia. So we need to know that the change is the new normal. We cannot look at what we have before pandemic. We need to look forward. We need to look positively the future. What we're going to do, how we align our business, right, our strategy towards to face the pandemic. For Malaysia, the digitalization and automation is something that looked by the industry and people, no matter who you are. Why? Like you and I. For me, now I'm in the room to share with you on this topic. We are work from home. Without the digital technology, like today we're using GoToWebinar, Zoom, and others, Microsoft Teams, and etc. We are not able to be here, right? I think some of you are not from Camp Valley as well. You're from other state of Malaysia. So that's why the digital technology, the digital software enable us for today, okay, for me to share with you. And industry also looking at the automation, okay. Some industry, as I say, right, mentioned, even though you can allow to operate, but you cannot fully, you cannot allow to use full capacity for your production. That's why you need to have certain level of automation so that your productivity can up to the level, right? I'm very humble to share with you all, because I know that some of you are expert in automation, and some of you are very expert in R&D in your business as well. Okay, yeah, I know that the MEPN partner also here, like Mr. Kemcha, Mr. Tiong, Mr. Mano as well. Another one is a low touch economy, because pandemic we need to keep our distance. Not like last time we can hug each other, we can shake hands. We can keep the distance, social distancing. A lot of business you try to avoid to go to the physical shop, like shopping center and here and there. You try to avoid, because now the pandemic is very fierce, right? Now come to the level of Delta, right? So try to avoid. So low touch economy is what's happening now. This statement actually already mentioned by the MIDA. Okay, no, it's a low touch economy. So we need some of the technology, like the platform, online business platform, maybe the virus, something, right, the sensor here and there to avoid the touching. Okay? And resiliency of the supply chain. This happened when the global supply chain breakdown since last year. Okay, the China is the first one who is the first country to lock down. Okay, nothing can come up from China. That's why it impact the whole world supply chain. Nowadays you say, oh, China now recover, but the issue is the shipment has been delayed, because the whatever shipment now is for the backlog. If you're an exporter, importer, then you know. Okay, now the shipment, the container fees is expensive, not cheap at all, and then there's some delay of the shipment. So the country like Europe, US, and Japan, right, they look into a alternative supply, the supplier. So the European, they look at the East Europe. European also look at the Southeast Asia. So we have a very good position in this area now. Okay, we can be a preferred location for the country like Europe, US, and others, right? The supply chain needs to be very resilient. And then medical product, of course, is a must now. We need to wear the face mask. We always need to use a sanitizer. Those companies that fall in this category to it become an essential industry. Okay, and then reliance on technology. So no choice, because of the lockdown, because of the restriction of movement, we need to depend on technology, not only for ourselves, for our business, for our operation, right, for our manufacturing, production, and etc. So we 2 days ago, yesterday, 2 days ago, MPC just launched the productivity report 2021. You can have a look. The key point for this one, actually I want to focus on this: boosting productivity we need to think about how to reset ourselves, reform, and rebound. Okay, we really need to always think positive on this. This is a very good theme. So COVID-19 become a catalyst for Malaysia Industry 4.0. Okay, as you know, national policy on Industry 4.0 already launched in 2018 October, right? Yeah, since then the industry, with the effort by the under the MITI, and then with the various agency support like MITA, MPC-MEPN, and others, right? They try to do something to encourage the local industry to move higher. They go for higher value chain. So they focus on the Industry 4.0. Now, because pandemic, restriction on movement, restriction on operation, right? Many people, many manufacturers, owner, they look into the Industry 4. How the Industry 4 technology can be enhanced, the capability, the productivity as well. So we have many experts in MPC that can assist you, like Mr. Kem Chua, Mr. Mano, and others are like, and as well as Mr. Vincent. Okay, this one, turbulence, is the best of time. So we think that there is a path forward. Okay, positive thinking. There's a path forward. How we going to do? Okay, what we should do if we look into the digital transformation. So normally people looking at, hey, I can focus very much on the business transformation. I think if you're owner, if you're bosses, tauke, I think you already transformed a lot since the beginning of your business. Why? You can say that, oh, I started with a small company, 2 people, 1 people only. Then I increased my number of the staff, 10, 20, 50, 100, a few hundred as well. This is called the transformation. During the transformation, you can see that, oh, I increase a manual machine, become an automate machine. But some people, they're very focused on the business transformation. But the problem, the issue for this is that you may not able to use digital technology to enhance your business. So you may miss the opportunity by using the technologies to enhance your business transformation as well. Another issue is that if you're too focused on the technologies, okay, but you don't look at the transformation on your business, right? Because I think most of you are having a very good awareness on the Industry 4.0. I think you attend a lot of webinar on the AI, IoT, cloud computing, and etc. Then of course, you can think that, oh, maybe I can use IoT to enhance, maybe I can invest more on AI, on the certain software to really enhance your business as well. But maybe you're not so focused on the business transformation. In this matter, you may fall in the trap that the investment, maybe a wasteful investment. Actually, you no need to have that, but you invest a lot, yeah, a software, but you're only having big use of 20% of software, but 80% you're not used for it. That's why you think about this kind of trap, wasteful investment. So we need to consolidate, synergize between the business transformation and digital technologies. We go for parallel. We go for transform our business at the same time. We look at the technology that available nowadays. The cost is very cost effective one. Okay, not so expensive because you need to base on your current condition, right? Your current cash flow. Okay, to look for the feasible investment on technology like software and hardware. So to go for it actually is to maximum the technology exploitation, as well as we look into the business impact. Okay, I know some of you, maybe you're facing a lot of issue on the human, on the supplier, rental, then you can think about how the technology can really assist you to enhance your capability and productivity. So for digitization, just to clear your mindset, digitization, just like before that, you were wearing the mechanical watch. Okay, now you change to the Casio digital watch. This digital watch is very easy. It's just battery inside. You can go for the sport watch as a sport watch. Can go for time, alarm, etc. This is called digitization. The next level is a digitalization. What is this? From the digital watch, right? You upgrade, become a smart watch. This smart watch, you can do a lot. Yeah, you can pair your wireless earphone to this smartwatch, and then you can listen to music, and then you can go for jogging, and then this watch can monitor your heartbeat, your distance, because it got GPS. This is called digitalization. You are increase the value of this the watch itself, right? Okay. In other words, it's a use of digital technologies to change a business model and provide new revenue and value producing opportunity. So the next level is a digital transformation, right? You can see you sell a lot of smartwatch in the whole world. This smartwatch is enable you to go for internet link, right? It got a Wi-Fi or the itself got a 4G system. Okay, for digital transformation, it's a rethinking of how an organization uses technology, people, and processes in pursuit of new business models and new revenue stream, driven by changes in customer expectation around products and services. I make it very simple. Behind the smartwatch, actually, is a big business. Why? Because the company that provide this smartwatch and the platform behind actually they capture a lot of data of yourself, of myself. What's the data? They know that the user, who is the user, male, female, age group, and the location, because we always on the GPS, right? And then from the data that capture, we know that what's the behavior of the group of people in this country, in this location, and etc. So this is the something, right? That's why the Lazada, Shopee, Amazon, this kind of platform, they capture so many data, and then from there they look at the data, they try to think about, what is a business that's feasible for this group of people, for this country, right? Digitization normally is looking at improve the business. This level is to make the organization is more efficient and effective. The next level, digitalization. The business can be optimized, okay, by how? To be a data-driven organization means that you capture information to optimize your business. From the data, you know that, why this machine always break down? It's because of this. Not because of, I tell you this, you think of this. At least the data can show that, this is the actual reason why this machine is always break down. Get the issue. You will know the actual issue is where. The next level, business transformation. Your company become a data company. From the data, you capture your client information. You can able to capture your product information in real time. From there, you know what to tackle. From the business, I think most of you know market data. For what? For you to realign your company, okay, to go for something that can make money, right? It's a very fair. Another side is an improved manufacturing. You can see that there are various methods applied from digitization, and digital transformation. From the beginning, as a unified operation view, you know, I use an Excel sheet to capture the data. Then I try to using IoT, Internet of Things, to capture data. Okay, then I apply certain level AI, artificial intelligence, to my process, okay, to capture, to understand the data. Okay, at the end, I can see that the highest level is a real-time capacity-based pricing. Why this? I know what's the market trend now, real time. I know how to position myself, what to produce, what's the price, right? Of course, there are a lot of information you need to capture. Okay, we look for the higher value of the business, right? That's why in here we not only look at the horizontally, we look at the vertically, and different angle. We need to look at it, different angle to capture whatever data is possible for us to realign. This is a graph by Singapore series. Okay, this one we look into the gap of from awareness to implementation. You all, right? It's very, I think Malaysia is very well in terms of the education. So we all know about, hey, what's Industry 4? What's the technology? What kind of software, hardware that available? But the issue is during implementation, normally the company, the owner himself, they don't know how to move forward, how to implement what is already know, right? You know about AI, you know about IoT, you know about robotic automation here and there, but how to move, how to implement whatever you think to transform is a challenge. So here I split into 4 phases. Learn your learning. Then you need to evaluate. What kind of evaluation? Look at yourself. Look at your company. Okay, I think you know about this method, right? SWOT, SWOT. You look at your strength. You look at your weaknesses, and then the opportunity and threat. Okay, then you realign. From here, you come up with something architect. You architect your strategy, your framework, your system framework, your company framework, so that you can move ahead. Okay, and then execute. Of course, after execution, not only you stop there, but you need to sustain the improvement. You need to manage your company, your team, your program. You need to innovate. Okay, not rigid. Nowadays, you need to innovate not only for your process, business, product, etc. And then you need to build culture, sustain it, and continuous improvement. That's just like the ISO CQI. Next one. Here, I would like to introduce the program by the MEPN, Machinery and Implement Productivity Nexus, the program called Productivity 1010. This one already informed by Dr. Mazlina, right? Actually, this program is an initiative to assist the businesses, the SME in Malaysia, like you all, okay, in the manufacturing sector or manufacturing related services to kickstart their digitization journey. So here we have a digitization self-diagnostic tool, as well as we have a program on the proof of concept project. Via training, we train you, and then on-site engagement, we handhold you. So the target is many business owner, CEO, engineer, technician in the manufacturing and manufacturing service related sector, where we MPC targeted about 5,000 companies for intervention, right? So this is the process flow. Okay, these are only for actual brief viewing. Okay, any inquiry, you can refer to Dr. Mazlina, Injit Rahman, and MPC. They will assist you, okay, to go through this program. So for this MPC-MEPN self-diagnostic tool, we look at the 3 main core. Okay, we look at the organizations, we look at the technology, and we look at the process. More or less similar to what you know, right? Some they're looking at the people, but here we look at the organization. In here we look at we assess on the leadership and talent development of the company and business and strategy. For technology, we assess on the connectivity, intelligence, and automation. For process, we assess on the supply chain, operation, and product of the company. But of course, this tool is a self-diagnostic tool. You can later maybe you can QR code, you scan it, and then you answer the question. At the end, you show the result. Okay, this is the scoring. Based on scoring, you can see that you are under the observer, beginner, learner, leader, or master. So from the left-hand side, you can see that this is the result. From here, you know that, oh, which area is your weakness. Then you can come up with some idea how to strategize your business towards a digital transformation. Right, it's something for you. Okay, please do support the program. There's another program we call as a My Reskill IoT program. This one to handhold the company to understand, what is the Internet of Things? Okay, how the Internet of Things enable to improve your process. Of course, I think you know a lot about the IoT, but some company, if you want to know more, want to implement the IoT in your process, please, you can always contact Dr. Mazlina in Egypt Ahmad for this program. So the next one is a program that I mentioned just now. Okay, this one actually to handhold the company. Okay, this one you use a industry grade Internet of Things. Okay, and then to show the proof of concept. Okay, from there you can see that with the dashboard as well. Okay, you can see that how the IoT able to improve your process. Okay. Besides that, this program also looking at to build the ecosystem of smart machinery industry. If you're the machinery and equipment manufacturers, you're welcome to join this, because we want to build the ecosystem for Malaysia machinery and equipment industry. So this is an integrated digitization strategy. Normally we look at the strategy that able to accelerating the customer value and growth. Because customer is a very important for us. Okay, because the customer is the one that can give us the profit, right? So we need to look at the digital vision, the leadership of a company. Okay, you have a very clear vision, and then of course you look at the product service ecosystem, engage your customer, engage your vendor, supplier, and you look at the operation system, right? Customer insight, technical insight, data enablement, continuous innovation, and digital culture. So of course, nowadays the very important point is that data. Data is a goal now. It's very important for you to understand your actual condition. Without data, without information, it's very hard to realign yourself to the planning. So from here, we talk about you need to build and sustain the momentum. Okay, not to say L project, after we finish one project, then we stop. Oh. Transformation, we talk about how we engage the employee, our team, our customer and partner engagement to sustain the continuous improvement as well as transformation at the end. Why the
Dr. Tan, echoing, yeah? Maybe you can check your other devices.
Here, I'm using the earphone. For my side?
Suppose it's come from your side.
Like, Mr. Mano.
Echoing.
Mr. Mano? Mr.
Let
Mano.
me check.
Yeah.
Project. Better now. No? Okay. A project for the technical error. Okay. The journey to start. You need to think about align company with a common approach to the digitalization stage. Okay, this is some of your idea for you. You need to embark a journey. Listen a lot, but no first step towards no go. Actually, you need to embark the journey. No matter how, you need to embark the journey. You can engage with the professional advisor, okay, that hand-holding you and work together for long-term partnership to grow the company, to transform the company. Of course, you need to learn to see, okay? Learn to see. We have to learn the process, learn the technology, learn how to improve your current process, right? Look into the pain point, okay, engage with a good partner, adopt the right technology to your process. You need to look into your own company, right? The employee, they are your teammate. You need to build a good team, okay, to enable you for the transformation. Okay, if you're worried of the wasteful investment, then you can engage, partner with the system integrator, solution provider for the proof of concept, whether to know that whether this technology is feasible or not, right? To improve your process, and then of course you develop a good loop mapping lah. Okay, look, this loop mapping is based on your cash flow. It's based on your yearly budget, and design your loop map. Then align the strategy as well. Okay, I think most of you have your own strategy, but here when you go for digital transformation, you need to align how this can compensate each other. And then always measure. Okay, measure back. Why you need remeasure a lot? Because you need to go for improvement. Okay, nothing. Sometimes you can start the thing very good success, but sometimes not. Then from there you try to realign yourself. Always look into standards and guidelines, because this standard and guideline is a guide for you, okay, so that you will not go to somewhere else. Okay, so there are a lot of ideas as well. Okay, I will leave it to Mr. Mano and others to share with you. Right, there's so many methods you can apply. Okay, next one I just show you some of the loop mapping lah. You can put the digital transformation program. You put the stage 1, stage 2, stage 3, stage 4, stage 5. Of course, digital transformation is a journey. Okay, you can put your transformation strategy as a short term, let's say maybe 3 to 5 years, or long term 10 years, like that. Okay, this is how we strategize. Of course, this one you know better. You're the owner, you're the entrepreneur, you know better your strength, your weakness. Okay, because every stages need to have what? The budget. This budget, you need to look at your sales, your cash flow, and etc. So lastly, I show the Cameron. Why? We need to like this animal. Okay, not because of what? You can see the changing color, right? So we need to adapt and transform. Lastly, the quote by Charles Darwin: "It's not the strongest of the species that survive, nor the most intelligent, but the one more responsive to change." So change is very important now. We look positive forward, we change to the better. Okay, of course, I hope that, I think we also hope that Malaysia can survive, and fight against COVID-19 and survive and bounce back our Malaysia economy. Hopefully this one will happen with the support from all the Malaysians. Okay, and then that's all for my presentation for today. I'm Chee Fai from Robolab Technology. And lastly, I would like to thank you again, the MPC, for the invitation for this sharing. You contact me via the Facebook, Instagram, or LinkedIn. Okay, thank you. That's all. Later, I will share with you for the Q&A. Thank you.
Okay, thank you for Dr. Tan Chee Fai for the very insightful presentation on the what is the between the he differentiate on the digitization, digitalization, and also the digital transformation after all. And then what he emphasizes, in order for us to start the digitization journey, we need to measure where we are first. So that's why MPC are introducing our productivity 1010 tools for the companies to assess your companies, by online assessment where you are in terms of the digitization. So actually, I got one question from Mr. Yu Leong Cheng. Maybe we will bring forward the question at the end of the session, and then without further delay, I would like to invite Mr. Mano to deliver his presentation on the smart machinery and how actually digitization can improve productivity. Please welcome Mr. Mano.
All right, just to test. Thank you, Dr. Mazlina. Are you able to hear?
Good.
Oh, okay, good. Just testing. Now, very good afternoon to all our participants today. And I would like to take this opportunity to thank MPC for inviting us today as one of the panel speakers on the subject journey to what? Journey to be to. Where is our title today? Okay, journey of the digital transformation. Sorry. Let me just switch the screen. I'm trying to see. Just to check, are you able to see my screen? My presentation screen?
Yes.
All right, good, thanks.
Okay.
Okay. Now, just to start, so we are requested today actually to share more on our experience in machine building with Industry 4.0 technologies. Let me see how I couldn't shrink the screen here. This is new to me. Okay. As such, we have selected the title on smart machines and smart factory, as well as productivity improvement through digitalization as our key point to discuss today, right? First, I would like to just introduce ourselves and to show you what we have done and what then from there we will go on with presenting the key points that we have considered in our machine. Okay, PSS, we are a company established about 40 years back in 1971. We have been building machines for the past 25 years, and we mostly provide total plant automation or turnkey solutions. We started our Industry 4.0 journey in 2016 on the request of a multinational company who wanted their line to be able to be ready with Industry 4.0. That's where we really started our journey. And since then, we have completed about 7 to 8 lines, all in Industry 4.0 ready condition. Okay, the keyword here is ready, because to achieve the full Industry 4.0, it is a much bigger scope. So we are only focusing as far as the machine or the line is concerned, right? Now, before we go further into sharing what are the features or what we use in the technology, what are the technologies we use in this our so-called smart machine, I would like to just touch a little bit on the difference in the industrial revolution, or 3 and 4. So basically, Industrial Revolution 3.0 started somewhere in 1960s when PLC or programmable control logic, sensors and actuators were invented, right? In the past 3-4 years or even 5 years, we've been listening a lot about Industry 4.0, and I believe we all already have a good idea of it. So I would just touch on the key points only, right? So Industry 3.0, the standard was very much already the beginning of digitization. So digitalization starts in IR 3.0, right? IR 4.0 is a further development of it. Yeah, and some experts are even calling it as an evolution, but it is actually known as the Industrial Revolution 4.0. And this started in around 2011 in Germany, And basically this era was triggered more due to the advancement in electronics, yeah, the power of electronics and networking, faster processing, more intelligent components, and higher bandwidth. So these have been the key factors where the new era of industrial 4.0 is being introduced, yeah, with the help of this new development. Now the main difference between the industry 3 and 4 is basically 3 is just a binary operation, on, off, and it's a one-way communication. Let's say PLC can check with a sensor, what is the state, how are you, finish, that's it. And it's a one-way communication. Whereas in industry 4, it is more on two-way communication. Here, the component itself have become more smarter, right? Like, let's say, for example, we take a sensor, the IoT sensor, yeah? These sensors now can give us more information than just yes, on, off, or yes or no, right? They are able to talk to us and tell us that, look, we have a open circuit, we have a short circuit, we have a sensitivity error, like somebody touched the sensor and it is out of the range, you know. And usage hours, like how many hours it's been running, which we can collect, right? These are the components are becoming much smarter, right? So they are able to talk in two ways. Then the processing power of all our PLCs and data processing becoming faster, and these have enabled very large volume of data to be able to be transferred, right, compared to our previous machine. So these are the main key factors or features of Industry 4.0 that we are looking at on the view of machineries and the plant, right? Now, first, I would like to bring in the key technologies that we have considered, right, from Industry 4.0 into the so-called smart machines, right? Here, we are not looking at every pillar that is available in Industry 4.0. We are only looking at the key pillars. In our term, we are looking at industrial IoT or IoT, horizontal and vertical integration. This is automation, autonomous robotics. Now, the difference is here we call it autonomous robotic rather than robot. Robots are already there in Industry 3, right? So when we talk about the Industry 4, we are looking at autonomous robots where they come with a little bit of AI features. They can do a self-calculated movements, right? So this is a little bit higher than the previous robot. Augmented reality in certain area of our troubleshooting and simulation. Now, Industry 4.0, one of the key or the basic of it is cyber physical system, CPS we call it. Now, it's basically digital twinning of our physical machines or the line, right? These have been one of the key features that improves or bring in the smart features to the new machines, right? The focus, now those are the technology that we want to use. Now, what is our focus? So our focus on a smart machine, what do we want in our smart machine, right? Compared to our existing technology, where existing technology, a machine is designed with a PLC with sensors, all they have to do is the logic of it. Let's say to pack a product, that's what it does. Move this, move that, and pack and turn, you know, that's logical. Now with a smart machine, that function remains the same. It is not changed, right? Only thing is we are enhancing it. We are adding on more features where data is involved. So the key point here in smart machine is data, right? Throughout our presentation, you will see that we are talking more of data and data transfer, as well as data processing and using it to analyze for the improvement of the machine features, right? So here the key focus being connectivity, which is M2M, machine to machine or component to machine, P2M, people to machine, right? These kind of connectivities. Real-time data collection. These features is a major feature of smart machine compared to the existing machine. A lot of data, right? Smart machines are mainly more on collecting a lot of data, right? Real-time data collection. So we can collect production data, individual product data, like each and every piece of product that goes through the machine, we can collect the related data. OEE, right? OEE is overall equipment effectiveness, which now with the higher processing power and the capability of the PLCs, we can collect OEE directly from the machine, right? Error logs, audit trail, every button that you touch in the machine is being now tracked. So you have audit trail, utility, right? Air consumption, power consumption, steam, gas, all these we can monitor now and keep the data, right? We will see how the data is being used later. And component data. Now this is the added feature. When we say component data compared to the previous machine, it is just a physical sensor which is on and off, right? Now, when you look at a component data, we are reading what are the information or the components information. We can know what is the brand, who made it, and all this, right? Next is the analysis feature. Basically, here in our earlier machine development, earlier stage, we try to analyze these data in the machine itself, right, to a certain extent. But later we realized that that is actually overusing or killing the power of the processing, and we are taking away a lot of speed on the logic part of the machine. The machine is supposed to do a task. It's supposed to do a packing, let's say. So we are taking away the cycle time, the speed, and that was not what we want. So as we grow further, we stop doing analysis of data on the machine itself. So now we introduce edge computing, or in the other term we call it line server. Edge computing or line server, what they does is they collect this data and the data is being analyzed over there, right? And the next one with smart machine is user management, where we know who is handling what on the machine, right? Here we look a little bit more in the connectivity part of it. So it's basically M2M, P2M. On the right, you can see here the different layers that we implement in the machine control, right? The first layer being the IoT devices, right? Sensors and other devices. Next level is the connectivity, where we use various type of connection. It could be a Profinet, Profilink, IO-Link, Ethernet, Ethercat, you name it. There are plenty of connectivity here available. Followed by the processing layer, PLCs. Here we have some names on it. So this is our earlier components that we use. Currently we are using them, as well as more new components are also being introduced now. Now analyze, so that the next level is we can have because of the improvement in power of PLC, now we can do a certain level of analysis in there, right? And either we want to store or we want to further communicate the data to the external. Yeah, these are the connectivity that we are looking at in a smart machine. Now on the data collection, real-time data collection. So production data, individual product data we can collect, right? Let's say we take a product A, whatever happens to the product, what is the image, or if we take an image of it, we can store with it, we can take the weight of it, we can check if it is a metal detected or not, we can check if it is an X-ray pass or fail, right? So all these information related to this product now can be tracked, right? We keep them in a record. And the next one is the machine and line data. right? Like OEE, utility. So all this data we can collect now. Error log. This is every machine error that is happening. We collect them. There is a use for it. We can use it for a post-mortem study or sending messages. We will cover that as well later. Audit trail. Audit trail, in the earlier days, whatever we touch on the machine, we don't really keep track of them. But today, with the availability of a higher data transfer and data collection, we keep a full audit trail of the machine. Which button, what time, who touched the button, all these features can be done, can be added, right? So like these are some of the displays that we had on current machines. The first one here is more of OEE screen where it is, we will be able to see the complete OEE, with APQ values as well. Like here, these are on continuously monitoring, and it will plot it out. We also project the times, how much of time that it have used or schedule, unscheduled, and the product quality itself. Right? The display at the bottom here, the customer requested. This is a line in Indonesia where the customer requests to monitor by line what is the output, what is the production, and stuff like that. Right? The advantages. Now we have seen the technology that we use in the machine and what are the information we can pick up from the machine using this technology. And now by having this information, what are the advantages we can gain from the machine? The first one is OEE. OEE is actually a very strong or powerful analytical tool, right? It combines the APQ values. So this will show how a line or a machine have been performing. We can use this or OEE from one line and compare with the next line to see how the different lines are operating, right? Or from one line in one country with another line from another country. Yeah. So this gives a very general or overview picture on individual line performance to the higher level management, right? Production and product traceability. Like what we said, we are collecting detailed information of each product, right? So here we can do that, as well as we can collect the total production report, like what is the total output, end of the shift, end of the batch, end of the day, things like that, right? And quick troubleshooting. Earlier we said that we track the error. Now the same error we can use to transmit to the technician if required, right? Okay, to the technician, where when there is an error occurring in the line, it can be immediately projected or transmit to a technician or a manager or an engineer instantly with a lot of detailed information, right? I'll also show that some of the sample screen on that. Error and audit trail logging, as well as energy data analysis. Now, OEE itself, the advantage of OEE. Here you can see OEE is overall equipment effectiveness made of availability of the machine, performance, and quality, right? So these three key features will make up the OEE. Like in this screen, we will be continuously monitoring the production as well as the time of different errors, different downtime, and it will be monitoring continuously. What's the main difference between now and the previous system? In the previous system, we will be using maybe a manual or an Excel form of logging. So there is always a tendency of a little bit of being biased. If the operator themselves can change the numbers as how they feel like to show a different performance. Here, you can't do that. It is the machine itself is calculating it. Like for example, when we define a certain time for a schedule, like a scheduled downtime, let's say to do a certain task, And at that time, the machine is still in production mode. The machine or the controller is not going to take or count that minutes or the time as a scheduled downtime. It is going to count it as production time. So eventually what you get as we is more transparent value, right? It's less manipulation done to it. The other thing is the production data. Like this one is one of our simple data that we collect from drum line. This is the drum filling line that we have installed. Here you can see that it's a full detail. Each individual drum data is being collected. Like this is the drum ID. At what time, what was the weight that it was filled, and at what time this drum went through a metal detector inspection, and at what time the drum went through a check weighing inspection, and what are the weights. And in case if we are taking a image of the camera image of the drum, even that we can store under the same individual drum information. And the SSTC is the International Pallet ID. So since there are four of these drums going onto one pallet, you can see that these four same ID here is being attached to these four drums. The next four of these ID of the pallet is attached to these four drums. Now here, this is what we call pack and track system. We have developed a pack and track where we use it to track the father-child link of the product. So we can trace from pallet to the bag or the what are the bags or the drums sitting on a pallet. And if it is, let's say, a carton box with a multiple piece of primary pack sitting inside, we can do another level of inspection where we know which are the packs sitting in the carton. So we have this father-child link established in our data itself. Now this is useful when there is when we want to go back and trace. Like let's say there is a report from the market saying that, look, I have this bag ID with me and it is underweight. Or even in this data, if somebody the customer call and say, look, I have this drum ID with me, which is printed on the drum and it is underweight. Immediately we can trace this from our system just by keying in the number. You're already able to know on which day, what time, what was the filling weight, what was the check weight, all the details at your fingertip, right? So this is for traceability of the product. Now, I said a little bit on the quick messaging earlier. So this is one of the advantages. Now, whenever there is an error being generated by the machine, right? This error, we will store it for analysis later analysis. The other thing that we can do is instant messaging. Like this email sample here is Malipi, or this is one of our project in Hewlett Packard, right? HP. This is actually one of our first project with Industry 4.0. This message will be sent to the engineers or the technician who is assigned. You can see the details that is being given there. At what time, the minute the error happens, this message is already in their phone, right? What time and what is the error code? What was the sensor actually, or the item, whatever the item that we are having error, the brand name, or here it's a IFM brand, model, what's the model and what's the type. So this is how we try to cut down our intervention time or the maintenance time. So by having this information in the technician's hand, the minute they see that, hey, looks like this sensor is having an error, they do not have to waste time going doing some detailed troubleshooting, top down, bottom up, whatever. All they have to do is go look for a sensor from the store, bring it to the line, because we have already even attached a real-time photo of the component, where it is, and the line ID is also there. They just have to replace the sensor straight away. And if the sensor, let's say this is a sensor fault and they're replacing it, and they replace with another model of a sensor, a new message will be sent immediately to them. right? Where it will be saying that this model is a wrong model, we need this particular model. So this is how we cut down the maintenance time or the troubleshooting time, right? By using the data that is coming from the sensor itself. The other advantage of these smart machines are energy monitoring. Like this chart here, this is what we call Smart 4. It's our own on-edge computing software where we monitor the complete lines, performance, and all the other related. Like this is one of our checkweighers in the line. You can see there is a utility button there. If we go into that, it will list out all the utilities that we are using. Let's say the power, air consumed by the machine, power consumed by the machine. So end of the day, by shift, by batch, or by day, these data can be grouped together and made into a chart. So the data will be helpful in determining how well our line been running. We can calculate total line or individual machine, right? The power that is used, the air, compressed air that is being used, or the steam, or even the processed water. It's all up to the customer. What do they want? The more you want the option, the better it gets. To cover the whole thing, what is our game, right? Now we have seen what are the technologies we use from Industry 4 into the machine, and out of using these technologies, what are the things we take out of the machine, like the data and information, and what are the advantages or the usage of these data, and the final thing is, what is the gain? Every dollar that we invest, there must be something in return. So the gain is production cost improvement. So by having a shorter downtime, better manage, better managed machine, where we can have a better production costing, improve efficiency, better product monitoring. This is by product monitoring system, faster changeover, right? And higher profit margin. So bottom line is profit margin. We have to make back something from what we expect, right? Now, since we have seen the idea of smart machine, a few of these smart machines will form a smart line, but here we call it smart factory so it covers both the overall. We will touch as the overall factory rather than touching the line itself. Literally, it's all crossing each other, right? What do we look for a smart factory, right? Now, before we go into that, let me touch again into Industrial Revolution 4.0 and a little bit what it really means and what for us as a machine builder. Industrial 4.0 is an ecosystem, right? It is not just a technology of, let's say, A or B. It's an ecosystem where it's created through digitization of economic and production flow. That's a clear picture there. It requires horizontal and vertical integration. So there are vertical integration from top down or horizontal in the line itself. From line, then we merge it up into the plant or factory. So there is both way of integration. In our work, normally, like for myself, I like to look at it as the term farm to table. Let's say for a food product. If we take a food product, Industry 4.0 will cover from the farm up to the product, the grain being converted into a product, and product to the distribution to the consumer. It covers the entire value chain, right? Industry 4.0 is the entire value chain of a product, okay? And it involves everybody. It involves supplier, procurement, design, manufacturing, you name it, the maintenance, logistics, everything related from one end until the other end, right? That is the full feature of Industry 4.0. And what we are looking at from our viewpoint or our area of expertise, only the smart machine, smart factory, and improvised production, right? The final result will be less wastage, storage, better monitoring and maintenance of machinery. Now, these are the 9 pillars of Industry 4.0, which we started using when we start in the 2016, 2017. At that time, the first 9 pillars were recommended by, if I'm not wrong, Boston Consultants. Boston Consultants were the one first introduced this as 9 key pillars. Today, I believe it is either 11 or 14. I lost count. It is still evolving. You know, it will evolve and new things will be there. And out of these 9, we only pick what we need for the machinery. So we are not interested in big data. We are not interested in cloud computing, cyber security. So we are more into the rest. IoT being our key feature, and the rest is simulation and system integration. Right now, this is a general chart that just to show you what this Industry 4.0 covers in total. It's in the totality of Industry 4.0 and where the smart factory sits. Smart factory is just a part of the total Industry 4.0. When earlier I say farm to the table, so the farm starts here, we already have smart farming, right? From smart farming processing, or that's a smart processing or another smart factory connected to this smart factory where the final product processing and logistics. The whole thing is being controlled, or the brain of this being the MES or ERP system and higher level MES like SAP, Amazon, you know, Alibaba Cloud and all this. This is the totality of Industry 4.0. Now, how does it works in this way? Like, let's say, for example, we take an example from the logistics, right, which is easier. When there is a reduction in a certain SKU, let's say a quantity hits a minimum limit in a smart logistics, in smart distribution, this will automatically trigger a call to the system saying that, look, I'm running out of this SKU by this much. Let's say that happens in Johor, and it's telling him. The system will analyze it and pick the right factory to activate the order, right? You could have a factory in Johor, a factory in Penang and Selangor, but since the order is from Johor, and it checks first for the Johor factory, is there capacity? If no, then what is the next nearest factory? And it goes on in this kind of analysis, and it self-determine which factory to be assigned to complete this order, right? So the same way, when that is assigned, it will also decide how much of material required, packaging material, raw material. It will initiate orders to the supply chain, right? So everything is linked with one another, right? And this is the total functionality of the system in Industrial 4.0. This is when it achieved its final position, right? Smart factory itself, this is the part of, like what I indicated earlier, it's just a part of the total chain, or the Industry 4.0, Industrial Revolution 4.0. Right? In smart factory, the smart factory itself is a leap forward already compared to the traditional automation, where the key points we are looking at is connected and flexible system, right? Flexibility and connectivity, that's a key features of smart factory that we are looking for compared to the existing factories, right? Or the normal automated factories. It utilizes the constant stream of data that is being collected from the line. It can be from the sensor, from the component machine, whichever. It's a continuous data that is coming in, and using that to analyze and to make the next level of decision. And this facilitates the formation of CPS, cyber physical system, or the digital twinning. Digital twinning is basically, we take a physical image of the current line or current machine, and we create an image copy of it in the cyberspace, right? let's say a machine we have with so many sensors and everything, the same image can be created in the cyber. And this is what we will put in the pad, or even sending the information, like, all these data can be worked out or analyzed in the cyberspace, whereas the physical machine itself does not waste time on this. It will continue with its operation, the logical function that it's supposed to do. A machine supposed to do a packing or a certain process, that's what it's going to do. But at the same time, it's going to use these smart components and pick up the data and transfer over to the edge computer to process it and to do the analysis for further enhancement of the machine. Right? Now, looking at the technologies that we wanted, which is connectivity and flexibility, what do we want? What do we focus on our life? So if you look at it, it is pretty much the same as what you've seen in the smart machine level. It is all about connectivity and real-time data. And in this case, the connectivity is the same thing, machine to machine or people to machine, and real-time data being production data, OEE, error log, audit trail, and stuff like that. And as I told you earlier, in our earlier version machines, we used to do some analysis of OE and other information in the machine level, but now these are done on the edge computing or the edge computer itself. So we transfer the data out to the line server or the edge computer, and that's where we do the analysis. From the analysis, also we can create a management report and user management. Right? Now, this is the same connectivity chart that you saw earlier, but here you can see that these are all sitting in the smart machine, and multiple smart machine is being connected further to the higher level where the reporting layer comes in, as well as the user interface. So we have made lines where we can use a pad, like an iPad or the Asus pad, to look at a complete line in our pad itself, right? And the technician can carry this pad and walk through the line and see different machine, what do you call that, is synoptics on his own screen, what is happening to the machine, what is the error, everything can be displayed on the pad in his hand, So the technician or the engineer have all the data, all the information he needs about the line and the operation, right? Then the other one is the people to machines, which is HMI and all this smartphone and all this, right? Real-time data. So the same information that we shared earlier, this is the product data, and these are the alarm, error, event logs, or the error logs that we transfer out, right? So here you can see the production data or product data. When we say product data, that is an individual data like this. And for production data, that will be more of like end of the batch, end of the shift. We will send one compile data. Okay, this is the total for today, right? Or by day. It is all, we can set it as we want. And OEE, which is we collect individual machine OEE, then we merge them together and to make it into a line OEE. Error log, audit trail, and component burnout time. So this is the additional information that we share here, which is earlier the machine will collect the life or the usage of component from the machine and transfer out to the edge computer. It does not analyze it. It just capture the value and send it out. We use those data to calculate the life of the component that is running on the machine. We will also touch that later on how it is useful. OEE is an important tool. Yeah, so it indicates overall line, and so this is a part of the analysis that we do in on the data that we collect from the individual machine, and these analyses are done at the edge computer level itself. OEE, we can check on individual machine. We can project individual machine OEE in a graph format or in a line format. instead of individual, we can look at it as a line, and it's useful in comparing from one line to the other. That tells us or give us a picture of how individual line is being performing. And we can go further deep into it. If we see that one of the line is giving a poor OE, then we can go further, drill in or drill down into it to look at the breakdown of APQ, availability, performance, and quality, and see which one of these components is creating the issue with the line or the machine. Is it the quality issue? Is it the performance issue? Or the availability issue of the machine, right? Error logs, these are useful in post-mortem study of the machine faults. So these analyses helps us to improve the machine performance again. So with the current machine, what we have is we have sensors, we have displays, we have information. When there's a fault, we correct it, we run it. And any kind of analysis we want to do, why is this problem keep repeating? We have to carry it out ourselves. Whereas here, the error logs are there, and we see the OE issue. We can start from the OE, we can check on the issues on which area of the issue, and then from there we can go for the error, find out what are the errors, how often it's repeating, why it is happening, right? And then to study further and use these as a tool to improve our machine performance, right? The other usage for the error is on sending instant messaging, where we flush out a message to the engineers the minute or the instant the error happens. Right? Audit trail is another function which is very useful for us. It tells us who, what happened to the machine, or who changed what. Every button that is touched on the screen, let's say somebody go and change some number, okay, they scan their user ID and we log it. We say, okay, this person at this time have changed this. So this also helps us, or this at this time, this minute, this motor trick. So with that information together with the error logs, this helps to improve or for us to analyze the issue with the machine and to improve the machine performance, right? The other good feature about the new technology is predictive maintenance. This is something which is very interesting, very good, because the component itself is able to share information with us. It is able to tell us, look, how many hours I've been running, how many hours I've been burning. Now, what we do is the machine will only collect this information and transfer out to the edge computer. At the edge computer, we run our PC-based software. I believe you have seen in the previous screens, we call it Smart 4.0, right? That is a program which will analyze or display as an overall, right? It's an overall line performance monitoring or data collection and monitoring software, right? So here, this system will collect all those sensor data and compare with the master list on mean time before breakdown, right? And it will generate a list of components which need to be prepared. Like when we know mean time before breakdown, the time is, let's say, 3 months. Then when the time is reaching there, or close to it, to the window, we already generate a message or a list of parts that need to be prepared, right, for the preventive maintenance. So before it's a predictive maintenance, right? And the utility consumption. This is more and more getting accepted because green technology, companies are going towards green technology, and we are looking at many ways of saving energy, right? And in fact, one of our machines where we have installed is a flow meter, compressed air flow meter. We are able to pinpoint and say, or give a message saying that we suspect this cylinder on this machine is leaking, right? Because we are monitoring the flow, we are monitoring every step of it, we are giving a warning. And when this happens, we also have a lock system for the incoming air, where it will block the incoming air and save the energy. Whenever the machine is not running or in a standby mode, we lock the air. So in this way, we are not wasting the air which is leaking out through these leaky or faulty cylinders, right? Management reporting. So this is one of the sample reports of customer. Okay, this is a line which we install in East Africa, where the customer wanted to have a full detail on daily basis. So this email will be published to the managers on daily basis. So when the manager comes into his office, open his computer, he have an email sitting in front of him saying, giving this report with all the details, line ID, SKU, what are the SKUs or the run yesterday, from what time to what time, and total duration, schedule, unscheduled downtime, and scheduled downtime because of the OEE calculation, and good, bad containers, and the total and wastage. You know? So all the details are right in front of him. He don't need to wait for another one more day for the line executive to prepare an Excel chart and submit to him. It's there, 7 o'clock in the morning, we already publish to the emails, right? At the same time, we also do a summary of defects that happen. Like here you can see no power happened how many times. So these are live data that we collect and we publish. So it's like a number of a period, there was no power once and it was for 50 seconds, right? And then low air pressure, there were no cases. Manual mode, how many times manual mode? Downstream accumulator, so this machine couldn't run because downstream was full, right? For how many hours or how many times? So this kind of all the errors that happen that stops the machine, we log them together, we group and we publish it. At the same time, there is this OEE and APQ values. What was the quality level? What is the performance and availability, right? So this is the way that we submit the data or a management report. And these are customized. So certain customer might prefer a different thing, then we will do it according to that. The other thing is the schedule life cycle support, which we call it life cycle analysis, to do the preventive maintenance planning and component list. So using those information from the component, we will analyze it, we will publish a component required to be prepared in monthly basis, right? So on a monthly basis or bi-weekly basis, the system will automatically generate a list of components that need to be prepared for the line based on its own analysis. It checked the life of the component and the component have burnt out so much, and based on the OEM's recommended mean time before breakdown, we are recommending that you prepare this component, right, for the next intervention. Now we go to the character that the key character that we look for in a smart factory. So these are some of the key characters, right? Connected, the system must be fully connected, right? Here I would like to highlight from the point we started with smart machine to this point, you will see that most of our discussion been revolving around data connectivity. You know, this has been the major part of Industry 4.0 as far as machineries and factory level is concerned. In fact, if you look at the total Industry 4.0 architecture or the totality of it, connectivity and data is the key point or the key factor that rules the entire thing, right? Data is being collected from every point of the system and it is being analyzed and being used to do all these intelligent works, right? So connectivity, continuous pulling data from sensor machine together with the production data, real-time data connection, and interdepartmental collaboration. So these are the main connectivity that we are looking at in a smart factory. Optimize, increase asset uptime, yeah, production efficiency, higher equipment efficiency, highly automated production and material handling, right? Shorter production life cycle. Now with the simulation, we are even able to cut down the new product life cycle. Like earlier we have to do a manual development. Now it is already in a simulation mode, and life cycle of a product is also getting much shorter now. Transparent. real-time linkage to customer demand and real-time tool for quick and reliable decision making. So this is what I covered earlier. The information that flows, let's say from the example I gave, is a smart logistic to the MES, and from there to the factory, and so these are all happening without people's intervention. That is the ultimate target of Industry 4.0. Today we have a planner who is sitting there and planning out and entering the information. Okay, I need to order this much of this, and on this date. Whereas in future we are looking at transparent data flow, which will system itself will generate all this. When there is a shortage of let's say product A in Johor, the system itself will generate the demand to the MES saying that, look, I need this much of product A to be replenished, and the system will plan out its own, how much of raw material it needs, how much of time it needs and everything, and start raising order to the suppliers. So when we talk about this, when we achieve a full Industry 4.0 environment, everyone must be in the same platform. Our supplier, the end user, the consumer or the logistic, and the manufacturer, everybody is sharing the same platform, because then the data flows without any limitation or any blocks. Yeah, so the data have to flow on its own, and it's planned on its own, and the MES itself will plan which factory should I select to run this product based on the availability of the factory, the capacity of the factory. You know, does this factory have this capacity to run this product? And based on all this, it will select itself. Okay, now the product is required in Johor, and I will look for a factory which is nearest to the location, right? And if not, then move to the next position. Proactive, preventive maintenance through life cycle analysis. So this is one of the major proactive functions, and automated restocking. So whenever there is a drop in the quantity, we just do a restocking. Earlier identification and suppliers quality issues. When incoming materials have a quality issue at the source, they already can update the manufacturer. Look, I'm having a quality issue on this, and automatically the system start changing again. It replan again, or it might switch to a different supplier according to what is required. Right? Agile, very flexible changeover and easy adaptation. Now, these are the key factors that we think it is important for a smart factory. Now, when we say we, here the key point is Industry 4.0 is not an absolute fixed technology or subject. It covers the entire value chain of the product. As such, it is up to individual or every company to decide to what level of Industry 4.0 they want to get involved with. So whatever we've been highlighting here are the technologies and the data that we collect from the technology that we have implemented, and we feel that these are good enough for us to collect the data and improve the performance of the line or the machine and the factory, right? So it is very much up to every company and every person to decide to what level they want to bring this to. Now, with that, the final benefits of digitalization. When we spend money, we need to have the return. So we need to know what is the final benefits of it. So the same as what we covered earlier, it is all about cost reduction, improve efficiency, better product monitoring, faster changeover, and higher profit margin. So these are the key factors we are looking at, right? And finally, the screen. Now, productivity will improve through digitalization. All right. And thank you very much. And that covers our final presentation today. Back to you, Doctor.
Yeah, thank you very much, Mr. Mano. Very informative, and you show the real examples from your very own experience, right? So we have actually fortunate to have Mr. Mano here share his experience on this one. So without further delay, because we are outrun of our time, so I would like to go straight forward to Q&A. Yeah, we received about 8 questions from the floor. So I will go for the question one. Question one come from Mr. Yu Leong Cheng. Maybe perhaps Dr. Tan, you can answer this one. Mr. Yu asked you whether you are using AI or machine learning to analyze the big data.
Okay, for this question, right? For this question, I think it depends to the condition. The big data for a certain level, you don't need to have AI. But for a certain level, let's say if you're using the vision camera, right, for vision inspection, there's certain AI behind it, right? Of course, if you go for the predictive maintenance or prescriptive maintenance, then you need to use the AI to be embedded inside. Okay, for big data, it's all depend to the client, to the owner, what they want to look at, or they want to look at something just a graph, or they want to know about the condition before it happened. It's all depend, right? AI can be embedded inside. In a edge computing, just like what Mr. Mano said, right? Edge computing, it can be embedded with the AI software inside, so that the data they capture from the machine, right, they can process in this so-called IPC, right, then send to the cloud or just direct to the dashboard to show the result, or to send to the smartphone, right, to aware, to alert the PIC, right, for action. So this is my answer. Thank you.
Okay, this question also dedicated to Dr. Tan. So Mr. Vera S asking he wondering, yeah, what happened to the industry forward, and how is new industry for industry revolutions policy difference?
Yeah, for this question, I think you have attended the launching of the new 4IR policy, right, by MOSTI. For industry forward or national policy on industry 4.0 is more focused on the manufacturing industry. Okay, the lead is by the MITI. For this, the new policy, right, which is a 4IR policy, right, it look at the more holistic area. It covers the other than manufacturing itself. If you look at the policy itself, right, even the focus of the core is a bit different. For industry forward, is focused on 11 technology enable. For this one, the 4IR under the MOSTI is only focused on the five foundational technologies, which is AI, IoT, blockchain, cloud, computer, PDA, big data analytics, and also advanced material and technologies. Is a bit different. So I think that's my answer for you. Thank you.
Okay, the question is come from Mr. Venu Chander. I combine both questions from him. So he asking to Mr. Mano, yeah, what are the main of the IoT architecture, and what one factors would most accelerate the benefit of the Internet of Things? Yeah, that's all.
Can you repeat again, Doctor?
One is more on what is the main component of the IoT architecture. It refer to the smart machine, and then another one is what factors would most accelerate the benefit of the Internet of Things. This means maybe he referred to the pillars for the Industry 4.0. Among the pillars, factors, which is the most can accelerate the industry forward?
See, basically, Industry 4.0 is all about data and connectivity. That is the basic fundamental of Industry 4.0. That's where it's all revolving around. Now, when we look at it, IoT is Internet of Things is more on data, the devices. The IoT is the devices that able to collect the data. Now, when we look at a machine, when we look at IoT of a machine, we are looking at sensors, actuators, motors, servo motors, and stuff like that, where they are able to collect or they're able to submit the data. The data in the sense that what is the fault, what is happening, like we can query a sensor. Like today's IoT sensor is not like the previous sensor where it just say yes and no. Today we can query, we can say, hey, how are you and how you doing and what is your status. So it will tell you, look, I'm okay and I'm having this sensitivity issue and I'm having this, and it's also telling, look, I'm aging and I'm doing this and all. So this is the IoT. IoT is bringing all this information. It's sending the information, and now just having the data is one thing. So we need to analyze it, right, to convert it into information. So that's where the processing comes in, right? So how it improve? Definitely it improve in the sense of faster response on troubleshooting and cutting down the downtimes. For our angle, I'm looking at more machineries and plant, yeah. So where it helps is on cutting the downtime by faster interaction. Hope that helps.
Okay, one more question from Mr. Yu Liang Cheng. How stable and reliable of the sensor transmission to the system? Application layer, specifically in the application layer, is to you, Mr. Mano.
Okay, so basically to say how reliable in today's connection, like I said, there are many ways of doing the connectivity. There is what IO-Link, Ethernet, EtherCAT, and Profinet, Profibus. These are all proven technology, and it's already been there for many years. And this I wouldn't be able to go very detailed on it because this is our experts are more on automation guys are there. And but definitely I have not heard any problem or any issues coming from this connectivity so far. They are very much more reliable. Like for example, I mean, if Mr. Yu want to compare between an old concept and today's concept, see the very simple example I can give is in an existing sensor, there is a 3-wire cable and no communication. It just tells us yes and no, or I'm on or off. When there is a wire broken, the system will not be able to determine is it the wire broken or is it the sensor is not turning on. So it doesn't even tell us that. It just say, it's off, finish. Whereas when we look at the today's IoT sensor, when a wire is broken, the system already acknowledge that, and it's already have that self-intelligent to tell us, look, there is a lost communication and the sensor wire broken. It can even tell us that there is a wire broken or a short circuit in the sensor, right? So that is a kind of reliability that now we are looking at in the connectivity layer.
Yeah, I think he added the question. So I think this question, your answer is perhaps can answering his question too, because he is emphasized on the since smart factory using many sensors for monitoring and collection data, how to ensure the accuracy and reliability of the sensor. So I think this question is already answered by Mr. Mano, right?
Yeah, I pretty much covered, I believe.
Okay, so for the last question we received from Mr. Hasril Husni. He said he's from the KLM Tech. Hi, Mr. Mano, your system only for packaging business line. Are you able to comply with semi-standard? Example, OEE SEMI E10. So, Mr. Hasril's question.
I didn't really get that question. What he wants it? He wants.
They said that, do you only focus on the packaging business line only?
Oh, okay. Basically, our main industry have been packaging because we've been doing that for last 35, 40 years. We do complete turnkey. But lately, what we have done is we have also gone into customized machine building. In the past 10 years, we've been doing a custom design machine for other applications, as well as plant automation. We have even gone into process plant automation as well. So this, as automation is becoming a key factor now, we are expanding ourselves into various automation, not only packaging, but packaging is our core, right?
Okay.
If it is automation, then definitely we are in other industry as well. We are in various industries.
Perhaps Dr. Tan, you want to add some more on the question? You want to add additional answers for that?
Yeah, I want to add something, right? The most important that when you design a system, right, any architecture, you need to refer to the standard, any standard, because based on the standard, you will not go to somewhere, right? Of course, just some Mr. Mano already mentioned there are so many standards around. You need to really talk to your consultant or system integrator, right, to strategize how you're going to move forward, right, to come up with the right system design, right, so that the anything that come later is easy for you to plug in. If not, you are having a difficulty to communicate with other standards, right? So this is my advice. Thank you.
Okay, thank you, Mr. Mano and Dr. Tan, on your answer. So before we ended our session, I would like to promote our program, our upcoming forums on the Smart Machine Technology Forum. So we have 5 experts will discussing on the issues of smart machine technology, and then with our moderator, Mr. Komarudin Jahidin. So stay tuned with us and follow our Instagram, follow our Facebook, and also YouTube for more news and also events. So thank you very much for your kind attention and attendance today. We hope you have a fruitful information and have added a new knowledge ataupun additional knowledge to our towards industry 4.0. Thank you very much.
Thank you very much.
Thank you. All the best. Stay safe and stay healthy. Thank you.
Okay, bye. Thanks to the speakers.
Thank you, MPC.